thank you for joining me. We currently have.
We both agree that your balls smell really bad.
How bad are we talking?
The name of this eruption is.
Oh, is this it?
The name of this volcano is basically Melanie. I named it right here. It's basically yeah. The name of this eruption, the name of this volcano is it's the Meradalir. Well, it's part of the Creature but
Nice.
Volcano, but the name of the vent is Meradalir. You have the Dollar volcano. This is Meradalir.
Oh my god.
Wow. He put the bicycle right in the path of the lava flow. Oh my god. Like, are you nuts? Like, what are you doing?
Held þessi hjólið að fara að brána eitthvað?
I need Icelandic here. Oh. Okay, so he didn't put it in front of us. So he didn't. Okay. I don't know. This is. It almost looks like this is just a compilation video. It's not like live. You know what? Yeah, this is not happening right now. Let's go to Volcano YT. You're gonna see some live eruptions. Wow, that is incredible. This is last year, but wow. That is some crazy lava fountaining. I mean, the monster comes out at night, and Etna decides to come out at night. Of course. Anyway, let's go back and let's look at history. You're making too much noise. There we go. There we go. This is what I was looking for. Good night. Yeah. It looks like thick fog has rolled over. You can't even see the eruption now. Oh, damn. You could definitely see the glow from the volcano. You can actually see the glow, but yeah. Just small up. Okay, so that was a 0.8 that occurred. Okay. Today is the 8th. That was a 0.8. The one that happened here. It happened this afternoon. That was a 0.8 magnitude earthquake. But here's the thing. You had another quake here, so it wasn't just a 0.8. You had several little quakes that were too small to be registered. Here, 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 and yeah. Let's see if that was registered. That was probably from a distance. Yeah. That probably was a small quake that just wasn't registered. Nope. Here. I see two areas of possible suspicion here and here. Maybe a little bit here. see that right here and here. Anything there? Nope. Nothing. Clear. Clear. Nope. Okay, let's see. Oh, a little bit over here. So you had a small earthquake. So you did have a small earthquake. Probably magnitude 0.2, 0.3. Definitely greater than a magnitude 0. So you did have a small quake. But here's the thing. Campiflagrei has been a lot quieter than recent. Like, if you look at the earthquake database, let's go all the way back to like March. The big earthquakes happened around March. Like April, March is when you had some magnitude 3s. This was like towards the fall. You had a 2.9 on the 19th of April. But the big increase in magnitude, boom, 3.6, March 29th. Depth of 2.49 kilometers. Yet if you look at the uplift chart, nothing major. Okay, so this is literally the only earthquake, basically. Maybe something here. And tiny little signal there. I mean, I've never seen Vesuvius this quiet. I mean, normally there's always like background activity here. Vesuvius has gone deadly silent. That's not good for Campiflagrei because that means if Vesuvius is so quiet, that means magma is flooding, is going more into Campiflagrei, which means that you're gonna have more uplift. Okay, so let's now look at. Hey, Johnny. I know. So you know what? I want. Okay, I want Johnny to be actually on the stream. I'm gonna call him right now. I know you are. That's why I'm calling you. Hold on. Let me put you near the microphone so everyone could hear you. Where's the microphone? Hold on. I think oh, there it is. There's the microphone. Hold on. Just give me some. Yes, we are. Okay, let me put you. Yeah. So right now, Campiflagrei just had an earthquake, small one.
Wait a second. Didn't you say that Campiflagrei is not as active?
It wasn't. Yeah, it hasn't been. But here's the thing. There was an earthquake around 4 a.m. local time.
4 a.m. Wait, our time?
No, local time, Campiflagrei. 1 a.m. 1:56 a.m. in England, which translates to here being around. Oh, sorry. Sorry, 2:56. My bad. So the earthquake happened at 10:06 p.m. local time here. So, not 10:06. Sorry, the earthquake happened. The earthquake happened at approximately 2:06. Yeah, 10:06. So about an hour and a half ago. Almost an hour and a half ago, the earthquake happened. 2:06. Yeah, so about almost an hour and a half ago. Small earthquake. I would say that's probably a magnitude.
Magnitude stronger?
No, like a point 0.2 or point 0.3. Very, very small. Small. Small
Wow,
earthquake.
that is pretty cool.
So right now I'm going to be looking at the uplift chart for Campi Flegrei. So right now I'm going to be looking at the uplift chart. Hold on. Johnny, my phone isn't working that well, so I have to...
What is your opinion about
Hold on, hold on. About what?
What is your opinion about geology of space reveal?
That's awesome.
I didn't think you would ever do that. I'm like, that ain't geology hub. And then whenever I heard his voice, I'm like, yep, that's geology hub. And that's what I think about it.
Okay, so let's look at the uplift chart. So the big earthquake, the 3.6, happened at the end of March.
The end of
March 28th it happened. So right around this time is when that big earthquake happened. Then you had a slight, almost like a brief decrease in uplift, like almost a little bit of subsidence. You had very little uplift, and now you're starting to have uplift again, which is causing earthquakes to pick up. Most of the earthquakes are caused by pressure on the fault lines because of the uplift.
Oh, upload. Oh, yeah, I see what you mean.
So the earthquakes that are happening at Campi Flegrei are not because of gases. This is what is known as volcanic tectonic earthquakes. So as uplift occurs, it puts pressure on the intra-caldera faults. And the intra-caldera faults are having earthquakes because of increasing seismic pressure due to the uplift of the caldera. So all of these earthquakes that you see here, this one here, basically all of these major earthquakes, such as the 3.6,
3.6?
that is not because of magma. That's indirectly. It's because of the uplift. The pressure of the uplift is causing pressure to build on the faults. You see how some of these quakes, they're oriented vertically and horizontally?
Yep.
Those aren't just because of just a grid pattern. That's how they placed earthquakes. No, that is because those are faults. Some of what you're seeing here are actual faults. There are faults that run in the Campi Flegrei region. See, these are basically faults. I'll show you a map of some of these faults right now. Okay, where was it? Okay.
Wow.
Hold on.
This volcano is scary.
There we go. Volcanic tectonic setting. There we go. Of the Pisciarelli Fumarole field. Here we go. Hold on.
Is all that red fall?
There we go. You see all these faults?
Yep. Those are falls.
So the uplift is putting pressure on these faults.
Yep.
So I was here. You see this fault? You see this right here? I was right along this fault scarp right here.
Oh, that's where you were?
Yep. I was along that fault. That's an S1 fault. S1 means it's a strike fault. It's a strike slip, basically. or that's how they named the faults, S1, S2. So this is the Solfatara, right here. This is the femoral Pisciarelli field. This is where I was, this area. And then there is basically a little mountain here, and this is where all the fumarolic activity occurs. This place was actually open to the public. The Solfatara was open to the public, but in 2017 a tragedy occurred. A boy fell into a fumarole. A ground opened up, he fell in, and 2 other people died trying to rescue him, including the boy. So 3 people died. 2 died trying to rescue him, and the boy also died. So it was a horrible tragedy. And after that, they closed off the Solfatara volcano to the public. Even the Pisciarelli field is actually closed to the public. So when I basically entered, I didn't know it was closed. Like, I did not know it was closed to the public. So right now, oh, Johnny, thank you. Did you raid me again?
No, I didn't even rate you. Wait a minute, what's going on?
I have 5 people viewing.
I don't know. Maybe I did. Who knows?
Thank you, man. You're the best. I just had a feeling you did it. You did. Anyway. Okay, let's look at the uplift. Okay. Looks like it's uplifting. You see this blue area right here? Hold on. You see this blue area here? See how it's going up again? It's uplifting again.
Uplifting?
Yes, again, it's having uplift again. So my belief is that it will continue to uplift, and we will end up being around the I think we'll be around when this year ends, like when we go into 2023, we'll be right around 260, 270 millimeters of uplift.
Oh my gosh.
No. Compared to 2021. So we'll have about 26 to 27 centimeters of uplift in 2 years. That is fast, but not as fast as Iwo Jima. They're having 100. They're having a meter of uplift a year. That's about 1,000 millimeters a year. Imagine it going like this.
What's VUP?
Huh?
VUP. What does that mean?
VUP? Where?
Yeah. VUP equals 13.2.
Oh, volume. V up. That's the rate of uplift. This is all Italian. So V stands for volume. UP stands for the direction up. See, millimeters per mesi. Mesi is how you say month in Italian. Mesi. So millimeters per month. So here they're saying that the series is as of January 1st, 2021. So it's the series. So let's go down. This is looking in the last 10 years. We have now had over 90. We've been having around 92 centimeters of uplift from 2011. 92. This is when Campi Flegrei was declared unrest. Here. Unrest. This is when they declared Campi Flegrei. It was alert level green. It's been alert level yellow ever since 2012. I mean, alert level yellow. It's been green until 2012. And from 2012, it was alert level yellow. And despite being alert level yellow, no eruption has taken place. I mean, look how much uplift has occurred. Do you know how much? That's feet of uplift. Meters even. 92 centimeters of uplift. Let's go centimeters to meters. 92. We've had almost a meter of uplift. But now let's go to feet. We've had 3 feet of uplift in approximately 10 years. But here's the thing, Johnny. Most of this uplift has occurred from around 2015. So let's look here. See, you had uplift, 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 and then nothing. It's just stable, right? You had no uplift for about a year. Everything was, normal for about a year. And from about 13, in the middle of 2014, is when the uplift to Camp Flegrei just exploded. It just took off. So in approximately 8 years, we went from 15 centimeters to 95 millimeters. So we've had approximately 10 centimeters of uplift a year. So this is 10 centimeters. Let's go to inches, right?
Let's go to inches.
That's about almost 4 inches a year of uplift. Nothing too crazy, but it's still pretty impressive.
That's scary.
I know, it is scary.
Wouldn't be surprised if that volcano erupts.
Johnny, I'm more concerned about Iwo Jima. But here's the thing. The problem with this volcano is that it's in a populated area. You have you have 3 million people that live within the danger zone of this volcano. 3 million people.
So what would happen if it was to erupt?
Most likely, you want the most likely first or the least likely first? Johnny, do you want the most likely scenario first or the least likely?
Least likely scenario.
Okay, the least likely scenario is it has a full-fledged eruption. Has a VEI 7. That's the least likely scenario.
How can a volcano that dormant erupt like that?
I'm sorry?
How can a volcano that lasted erupted in 1537 erupt like that? Ain't no way.
1538?
Oh yeah.
Here's the thing. This volcano is composed of 2 magma types, trachyte and phonolite. Trachyte and phonolite, and some rhyolite. And all phonolite and trachyte are both high in silica, with trachyte being the most silica rich. The thing is,
What does silica do?
silica is one of the most common minerals in the earth. Silica causes the gases to bind to the magma. It causes the magma to become more sticky, basically with gas. So it causes gases to be trapped in the magma.
Hey Andy,
Yes?
is it safe to touch lava?
No.
So like someone were to take your hand and just hit lava for like not even a second. Is that dangerous?
100%. They will have third-degree burns and their hand will have to be amputated. Yes. Extremely dangerous. And the thing is, magma is liquid. So what it's going to do is going to stick to your hand and it will literally melt your hand away.
Yee, that's
So like initially you'll have a reaction where there's gonna be if your hand is wet, you'll have like a brief, like maybe a nanosecond where the steam will create a cushion, but after that it will burn your hand. You'll have extreme horrific burns. Like I don't even want to go into detail about what will happen.
and the question is, how can somebody like Georgia, how can they get so close to lava where it doesn't even bother them?
Basically, they were far from the lava flow itself. They were far from the erupting vent. They were about several hundred meters away. And even with that, Geology Hub said it was 170 degrees.
How is that even possible to be that kind of, that's why, that's...
Magma bodies generate a huge amount of heat. Magma is literally molten rock. It's literally like... The rock is so hot that the rock is molten. It's in a liquid state because it is so hot.
I see.
Basalt magma is the hottest. That's why it's so liquid. The hotter the magma, the more fluid it is.
More fluid?
Yeah, the more liquid it is. However, you could have andesite that is more fluid if it has low gas. But if andesite is high gas, it will be explosive.
What does andesite look like?
For example, the reason the
what?
the reason the volcano, the La Palma volcano, was so explosive was because while it was basalt, it had a high gas content. It was very high in gas, even though it was low silica.
High in gasite?
I'm sorry?
Wait a second. Wait, what is 2023? It says 2023 and it's like right by that.
What?
Okay, the page is.
No, that's the year. That's the year.
Oh.
So we're in 2022 here.
Okay, what is 2011, 2000? Oh, wait, no. Okay.
No, Johnny, that's the years. That's when it started. So it's just showing the years. It always shows the next year, so like you'll know where you are right now. So you'll have a bit of a gap. So you'll know basically where you are. We're about here.
Okay, what does 5, 10, 15, 20, 25, 30, 35, 40...
Millimeters, centimeters. Those are centimeters.
Like, right?
See, variant of quota, which is the variance in centimeters of uplift. This is centimeters.
Okay. Is there any uplift at Mount St. Helens?
No, not right now. There's no uplift.
Wait a second.
And all of these, you see RITE, ACAE, SOLO, and STRZ, these are all GPS monitoring stations. These are GPS stations. The RITE station, which is in the city of Puzzoli, in the RITE location, has had the highest uplift.
Where's that at? Pasoli.
Puzzoli, it's a town in the Campania region. It's basically a suburb of Naples, Italy. It's a western suburb. It's on the coast.
So, like, if Campi Flegrei was to erupt, what would be the number one warning signs of it possibly erupting?
Well, you would have extremely rapid uplift, probably about a meter or two a day. Well, a meter or two. You would probably have very sudden uplift. I don't mean like this. Like, you would probably have uplift upwards of 2 to 3. You would probably have uplift before the eruption, like a few days, maybe a week, of several meters per day, or at least several centimeters a day. And right before the eruption, you'll probably have a sudden overnight uplift of several meters. The last time that happened in 1538, the area around the erupting vent had 17 meters of uplift in only a few months. 17 meters. However, that is the exception rather than the rule. In most cases, there is very little uplift or some uplift before a major eruption at Campi Flegrei. At first, this was the location that had the uplift. Most of the uplift was in Puzzoli, in this here. Then the uplift stopped, and then you had another area of uplift that was concentrated near what later became the erupting vent. So this is the central caldera. This is basically the central caldera itself. Right now, the only area that is really experiencing uplift is the central caldera. Basically, the resurgent dome is experiencing the most uplift. That means there's basically several magma chambers under Campi Flegrei. So you have a magma reservoir that feeds both Vesuvius and Campi Flegrei. Then you have each volcano, both Campi Flegrei and Vesuvius, has their own magma chamber, and closer to the surface, you have smaller individual chambers. Basically, areas where the magma can pool and then erupt. Like, even an area that has not had an eruption before can form a new vent. Campi Flegrei is basically a volcanic caldera and a volcanic field. So that's why they call it Campi Flegrei, or the burning fields, or Phlegreian fields. It's basically a volcanic field within a caldera.
Wow, that is very.
Yeah. And most eruptions at Campi Flegrei are monogenetic, means they only erupt once. After the 1538 eruption that formed the Monte Nuovo volcano, that area never erupted again, and it will probably never erupt again. So if you look on Google Earth, let me show you Google Earth. Let me show you Google Maps. So let's look at Pozzuoli.
What in the?
Hold on, let's look at Pozzuoli right here. Let's look at layers, right? See? You can okay, can you see all of the...
Remember, the stream is delayed, so
Okay, Johnny, can you see all the craters, right?
Yeah.
See? Craters, craters, crater, crater.
I can't see nothing. It's delayed.
Oh, right. So you see all these craters?
Oh my goodness.
That's Monte Nuovo. Again, another crater, another one here.
Question.
Little craters here, here. All of these areas are basically... So this is one big caldera. You could almost see two caldera outlines.
Okay, the super volcano that's near Naples, didn't that used to be one big stratovolcano?
No, no.
Wait.
It never used to be a stratovolcano. It was always like a volcanic field. Before its big climatic eruption, I mean, before its first super eruption, it primarily formed lava domes over a wide area. It never was one stratovolcano.
Where's Mount Vesuvius on that map?
Here,
Where is it? I don't see it.
right here. As I said, it's delayed.
I know it's extremely delayed, which is something I don't like about it.
Okay. Okay. So desktop audio.
I can turn up the TV and I can show you how delayed it is.
No, I believe you. I know. Okay, so these two volcanoes share a magma reservoir. In fact, this volcano here, and this group of volcanoes here all share a magma reservoir.
Large cracks open near Grindelwald.
I'm sorry?
Large cracks open near Grindavik in Iceland.
Well, yeah, that's the volcano that's erupting in Iceland. Right now, I'm focusing on Campi Flegrei. This is the most dangerous volcano right now because it's in a populated area. You're having a major volcano right in a city of millions of people. I mean, look at this. You're having a city with millions of people, and Campi Flegrei actually goes into parts of Naples. If you look at downtown Naples, look how close the volcano is.
That's very scary.
Yeah, it is very scary. Pozzuoli is here. So this is where Pozzuoli is. Here, right here, you're already in Naples. So basically, Pisciarelli is right on the border.
Andy.
Hold on. So Pisciarelli. Oh. Hold on. So Fumarole Pisciarelli right here. So right here is so Astrani is actually in Naples. So all of this here, via Pisciarelli, once you reach here, you're already in Naples. This road here is basically the the city limits of Naples, right here.
Andy,
Yes.
which volcano is deadlier, Mount Vesuvius or Campiflagray? Which one do you think is more destructive?
More dangerous? Absolutely, Campiflagray. 100%.
What about Mount Vesuvius? That's like the most obvious volcano that's in sight.
This volcano, Campiflagray, wiped out the Neanderthals. So basically,
Wait. Does
a
Mount
large
Vesuvius-
part of Naples is actually inside the caldera. So you see this here is inside the caldera. This is Naples.
I can't see it. It's delayed.
I know. Okay, so you see Sacavo? This is all inside the caldera. So anything left here, to the left, to the right, is in Naples. So parts of the city of Naples is actually in the caldera. That's why I'm doing Naples, see? Right here.
Yep. I see the little old Naples.
See, the city of Naples, a good portion of the city of Naples is in the caldera itself. Look at
Did
this.
you say that you've been to Naples before?
Bagnoli. You see Bagnoli here? You can actually smell sulfur here.
Ugh, that's not way.
You can smell sulfur. When I was taking the subway, there was like a little underground subway.
Sulfur. Is that a sign of a volcanic eruption?
When I was at Puzzoli here, I was sleeping right here.
Scary.
Where was I? Via del Emporio, right here.
Uh-huh.
See, let's type in lodging, right? I was sleeping right in this place. Reales Vista Mare, right here.
How can you say that so well?
Reales Vista Mare, because it's Italian. Like I know how to pronounce certain words in Italian. So I was right near the port of Puzzoli, Porto di Puzzoli, which means port of Puzzoli. So I was here. This is the hotel I was staying at. Really nice place. I recommend you go there. And you also get a free breakfast. You get a free breakfast at this restaurant here. You get a croissant of your choice. Well, basically any pastry with a small coffee. Okay. Anyway, I was here, and every morning, especially if there was no wind, I would smell sulfur. I would smell sulfur.
Sulfur dioxide?
No, I would smell sulfur, not sulfur. I would smell what smelled like rotten eggs. You know, like when. You know what sulfur smells like? Natural gas?
Smells like rotten eggs.
Yeah, that's exactly what it smelled like. And I wasn't even anywhere near the vent. I was here. This is where I was. I was here.
Wait, then how can you smell it?
Because two possibilities. Probably there was like small little like fissures, not fissures, like vents that were emitting small amounts of sulfur, or some of the because there was no wind, so some of the sulfur from the fumarole would whiffed over towards the area.
Does Fagradalsfjall have any fissure systems?
It does, but here's the thing: at night, early in the morning, I would smell the sulfur. Not during the day. It was either at night, late in the evening, or if there was very little wind. I mean, see, there's a lot of inexpensive places. Right now, it's more expensive because it's summertime.
Wait, is that U.S. dollars or their dollars?
U.S. dollars.
Wait a second. Do they take United States currency? I don't know if they do.
If you pay with card, yes, they do. You can pay over the phone.
Wait, so you're saying if I was to go there right now, if I had my...
If you paid with your card, yes, they would be okay with that.
Okay, like with American money, that's kind of
No,
weird.
they don't accept cash. They accept card payment.
Just card, like, so like...
Or euros.
So like if somebody from the United States would go over there, they...
Johnny, I want to focus on the volcano right now.
Oh, okay.
I don't want to focus on like the small stuff. I want to focus on the volcano itself. So right now, let's look at earthquakes again. So no change. That's good.
Okay, let's talk about the volcano in Iceland, like the tiles.
Hold on. Hold on. Okay, let's look at latest earthquakes.
Yeah. Go to the one.
Oh, look at that. There was a good earthquake in California, a little swarm. This is not volcanic. This is related to the earthquake that happened about last year.
Observatorio Vesuviano. What is that?
What?
It says something about Observatio Vesuvio.
That's the Vesuvius Observatory.
Wait, huh? US.
No. That is the Vesuvius Observatory. That's the website I was using for all this.
What website are you on right now?
Right now, USGS. I just switched over. As I said, there is a lagging time.
Dang it, I hate when it lags so much.
Johnny, people are watching. There's about 6 people watching.
Well, congratulations. I can see why, because you see, originally you're supposed to be talking about the volcano in Iceland, but you're talking about other volcanoes, which is...
Well, yeah. The thing is, the volcano in Iceland, there isn't any video about it. It's completely grayed out because of the rain.
Wait a minute. Yes, wait. Yes, there is. There's plenty of videos about that.
No live videos. Like right now, there's nothing live.
Oh, no live
See?
videos.
You see all the clouds are covering the volcano? See? Yeah.
I wonder if there's been any what? Oh, I can't see the map. All I see is magnets.
I know. Hold on. Johnny, hold on.
I want to see if there's any volcanoes.
This is not right now. This is an old video. This is basically what's going on at the volcano. See how it's acting up? This is what was happening earlier today. Look at that, Johnny. This is actually not Meradalir. This is actually Meradalir. This is Meradalir. Yeah, I see the bots. Yeah, I would have just deleted that. Basalt, that's basalt. You see how fast it's moving? That's 100% basalt. No, basalt. This is basalt.
Of all types of lava, or is it just one type?
It's primarily one type. Iceland almost always erupts basalt. Besides Eastern Iceland, which has bimodal volcanism, basaltic and also rhyolitic. But Iceland is like 90% basaltic magma. What is it, Johnny?
You paused it. Oh, never mind.
This is basically a combination. This is basically an upgrade. Oh, look at that. Spatter cone.
Oh, das sieht cool aus.
Yes, all spatter cones are basaltic lava. Almost always. The biggest spatter cone, I believe, is in Hawaii. Most spatter cones barely get about 50 meters. What happened in Spain? That was not a spatter cone. That was a cinder cone. Yes. I know. Let's not focus on that because I don't want to get stuck. Anyway, let's focus on the volcano. That's what people are here for. Let's not talk for now, okay? Let's just stay on the phone. So yeah, basically, this is a spatter cone. But it's not really a spatter cone. Let's not. Okay, so let's go back now. Yeah, this is not live. Hey, the bots are gone. This volcanic eruption will end around October, November. Basically what Geology Hub said is that now the volcano has changed to producing a lava cone forming eruption. A lava cone. Or not lava cone, a spatter cone forming eruption. Lava cones are actually the rarest type of volcano. So basically, this has basically transitioned to a spatter cone forming volcano. So the thing is, now that the vents are, it's no longer vents, but now is a spatter cone, you will start having eruptions where you'll have almost nothing, then it will produce spectacular lava fountains. Based on what is happening right now, I think the eruption will end between October and November, probably end of September, around the middle of October, is when this eruption should end. That's what Geology Hub didn't give a timeline on when it's going to end. He basically gave the eruption, how the eruption will progress. But based on how far it's already gone, the eruption will end. The eruption will cease in somewhere in October. Middle of October should end. Probably like middle, end of October, it should probably, the eruption should stop. I wouldn't be surprised if it's a little sooner, but I think in about a month, about 1 to 2 months, it should stop. And I'm basing this on the Galvin-Lawler thing. So let's look at earthquakes in Iceland. So let's look at earthquakes right now. Like intrusion, yeah, so that's basically what happened. Let's look at earthquakes right now. Earthquakes are still ongoing, but they're less frequent. Ooh, look at that. You had one earthquake around the So this volcano is Orekayayofel. Orekayofel. It's hard to really. That's the very dangerous Ore. Orekayayofel. Orekayofel is a volcano. It's actually very dangerous. Magma type. This volcano is actually the most dangerous in Iceland. Well, it hasn't erupted in several hundred years, but this volcano, Orekayayofel, is actually the most dangerous volcano in Iceland. This volcano, this volcano hasn't erupted in almost 300 years. What? Pinatubo. Hold on. Look, as Orefayokal volcanic belt pushed towards the east from the main volcanic line in Iceland, it started to have more infrequent eruptions. In the beginning, the volcano was constructed of thick layers of regular Icelandic basalt. But as time moved on, it started to produce ever more evolved magma, richer in silica, transcending through andesite, dacite, into the rare realm of erupting mainly rhyolite. The rhyolites at Orekayayofel contain between 70 and 75% silica, depending upon if the sample is taken from the tephra falls or from the extruded domes or spines on the top of the volcano. Normally, this would be rather sticky, but due to a neat trick of nature, the rhyolite at Orefayokal is both rich in gases and unusually hot. This is caused by repeated intrusions from depth into the system of basalt that delivers the usual for Iceland high content of volatile gases, and also functions as an ample heat source, keeping the rhyolite merrily boiling. That is very bad. Sometime during the last interglacial, the volcano suffered a major eruption in the form of a large VEI6 eruption that gouged out the caldera. During the end stage of that eruption, several rhyolite spines and domes were extruded, among them Havansdalsjökull. About a couple thousand years ago. During the Holocene, there have been no less than 5 known eruptions. The first are broadly constrained in time. We all know is that they happened after the last ice age and prior to colonization. One of those was yet another VEI4 explosive event from the caldera, and the other 2 were flank events with rhyolite lava flows and dome extrusions. Okay. June 1362 was the last eruption. Well, actually that was a pretty big one. Hold on. Even though this was a far smaller eruption, rated as a mid VEI4, it was still almost as deadly as the first one for the residents that had picked up farming below the mountain. Once more, a major but smaller Jökulhlaup roared forth and swept away farms. A Jökulhlaup is basically a lahar. It's basically a flood, a glacial flood, and swept away farms, churches, and assorted people and animals. And once more, ash and tephra took its toll. It is estimated that a full 2/3 of the residents perished this time. At least one priest survived and wrote a highly chilling account of the devastation. This eruption was also long-lasting, and it did not end until well into 1728. So it lasted for almost like half a year. Wow. What is apparent is that there is a silent zone between the deep earthquakes and the later upper earthquakes. This indicates a slightly off-center magma chamber, roughly the size of 20 to 40 cubic kilometers at about 17 to 14 kilometers depth. It is quite likely that there are smaller chambers higher up filled with extremely evolved rhyolite, but these would not be visible on these types of plots and would need far more earthquakes to find and accurately reproduce. Wow, that is amazing. That's a caldera. So it's basically a stratovolcano with a caldera. Yeah, they are. Oh, please subscribe. Wow, 8 viewers, incredible. So basically, let's look at Campi Flegrei. The earthquakes, okay. Well, I'm gonna be going to bed in like 30 minutes. Oh my god, I'm so tired. So now let's focus on the weather. Yeah, what is it, Johnny? What?
Do you know I showed speed on YouTube?
I can't hear you very well. Can you speak into the phone?
Do you know I show speed, that YouTuber slash streamer?
Not really. Never really heard of him.
Oh.
I mean, who is he?
He's like some type of streamer. I'm trying to remember what the frick happened to this thing. Let me see.
Wow, look at that Pacific hurricane. Oh, Hmm. Look at all that rain in Arizona. Look at this. Look at the monsoon. Monsoon is going crazy this summer. They need it really bad.
What about the tropics? What's gonna happen here?
Well, let's see. Atlantic. The GFS is trying to hint on something, but oh, there it goes. Yeah, as I was right, it's gonna go out to sea. Yeah, see, it's gonna go out to sea and into Canada. So basically, North America. Oops, wrong model. The European is trying to hint on something. Like the European is really trying to hint on something, but you see this coastal low here?
Yep, I see that.
That's probably gonna shove it out to sea. Let's go to spaghetti models right now. So we have a tropical wave, but a lot of the models are showing it's gonna go out to sea. So a tropical wave continues to produce a large area of disorganized showers and thunderstorms over the eastern tropical Atlantic, a few hundred miles southwest of the Cabo Verde Islands. Gradual development of the system is possible, and a tropical depression could form by the middle or latter portion of the week before environmental conditions become less favorable by this weekend. The system is expected to move westward to west-northwest at 15 to 20 miles per hour across the Atlantic over the next several days. So basically, it's going to become a depression and then it's going to be sheared apart.
If it survives, wait, oh, I see. It becomes less favorable by the play.
Okay, if it's stronger, it will go further north because the high pressure system, stronger storms are more easily steered by high pressure, while the system is weaker, it will stay further to the south.
Life had torn you.
No, it's going to go out to sea.
What about, wait, that's just crazy because it's August 8th and we only had, what, 3 systems? That's kind of,
I know.
that's kind of weird.
You know why this is happening? Because there's several reasons. So let's go to the sea surface temperature anomalies. So here's the thing. The Atlantic is pretty warm. But here's the thing. You're having a lot of Saharan dry air, which is impeding development. And also the MJO, the Madden-Julian oscillation, is in its negative phase. So right here, let's look at the MJO. So green is subsidence, basically. Not subsidence, is unfavorable for development. You're having an area of sinking air, while red is rising air. So basically, what this model is showing is by September, we should have some favorable conditions in the Atlantic. As this blob of rising air slowly begins to meander into the Pacific, and then another area of favorable conditions should should be moving across the Atlantic. So right now it's showing neutral conditions across the Atlantic. So some subsidence, some neutral. But so it could go either way. But right now you're having a lot of Saharan dry air. So you're right now not having a favorable environment for development at the moment.
Look at that orange.
That orange is actually rising air. That's an area of rising air, basically. So basically, if this was in the Atlantic, we would be having a lot of systems or a lot of potential for development.
Remember, just because it's quiet, don't let it fool you.
I'm sorry, Johnny?
Remember, just because it's quiet in the Atlantic, don't let it fool you.
Actually, this supports a very active Pacific.
Yeah, wait. Now, I'm going to tell you this. Think about it. If the Pacific Ocean is very active right now, just think within the next...
No, this is the Central Pacific. Right now, it doesn't look too active. Like right now, you have about equal chance of development. But here's the thing. In the Pacific, you don't have dry air coming from Africa. You don't have a big desert in North or South America. You have a little desert in the Southwest, the Mojave Desert. But really, you don't have a vast desert like the Sahara. You don't have the biggest desert in the world on your doorstep. In fact, the Sahara Desert will not always be a desert. The Sahara Desert only became a desert in the last 10 to 20,000 years. The Sahara Desert became a desert only in the last several thousand years. And this is not the first time this has happened. Every 20 to 30,000 years, as the Earth wobbles on its axis and the precession around the sun changes, you have a change in where the highest sun angle is. So basically, the Sahara Desert fluctuates between being a savanna and being a full-fledged desert. That is why when Rome... Hold on, Johnny. That is why when Rome first began to go into Africa, you had lions in Algeria. You had lions in what is now the Sahara Desert. You started finding lions in Algeria, Sudan, Libya. There were lions in North Africa.
Lions?
Yes. Do you know how the lions were able to be shown in Rome? because there were lions across North Africa. Only in the last 10,000 years, since the end of the last ice age, did the Sahara Desert transition from being a savanna once again into being a desert. Scientists found evidence in the Atlantic Ocean, deep down, areas of dust, no dust, layered upon each other. So dust, like sedimentary, and then sediments from like runoff and rain. So there was like layers of dust, then no dust, then dust, no dust. So basically alternating layers. Why? Because the Sahara Desert fluctuates from being a full-fledged desert with dunes to being mostly grassland, like the Great Plains. So basically the area of the trade winds shift north and then south, north-south. So what is today, you know how you have rain, tropical waves going off the east coast of Africa? Like south of the Sahara? That area of that rain belt then shifts north. And then south. North then south. It fluctuates several hundred miles every few thousand years, basically. The next time the Sahara Desert should fluctuate back to being a savanna is in about another 10 to 20,000 years. The Sahara Desert was not a desert for millions and millions of years. It actually fluctuates. Fact.
463 knots, 2 miles per hour.
Isn't that exciting? I mean, so imagine no Saharan dust. Imagine.
Sahara dust. Oh, that'd be kind of scary.
Yeah, that would be scary.
So if there was no Sahara dust, no wind shear, no dry air, we would all be screwed. Oh my gosh, I'm 37 views? What the frick?
See, Sahara Desert fluctuations. Look, read this.
It's very delayed. Remember, I can't see it. It's
Okay,
delayed.
okay, then wait like maybe a minute. Hold on. Let me read this. Just let me read. The Sahara's green shift happened because Earth's tilt changed. About 8,000 years ago, the tilt began moving from 24.1 degrees to the current day 23.5 degrees. Space.com, a life science sister site, previously reported that tilt variation made a big difference. Right now, the northern hemisphere is closest to the sun during the winter months. This may sound counterintuitive, but because of the current tilt, the northern hemisphere is tilted away from the sun during the winter season. During the Green Sahara, however, the northern hemisphere was closest to the sun during the summer. This led to an increase in solar radiation, in other words, heat, in Earth's northern hemisphere during the summer months. This rise in solar radiation amplified the African monsoon, a seasonal wind shift over the region caused by temperature differences between the land and ocean. The increased heat over the Sahara created a low pressure system that ushered moisture from the Atlantic Ocean into the barren desert. Usually the wind blows from dry land towards the Atlantic, spreading dust that fertilizes the Amazon rainforest and builds beaches in the Caribbean, Life Science previously reported. This increased moisture transformed the formerly sandy Sahara into a grass and shrub covered steppe. According to the National Oceanic and Atmospheric Administration, as animals there prospered, humans did too, eventually domesticating buffalo and goats and even creating an early system of symbolic art in the region, NOAA reported. But why did the Earth's tilt change in the first place? To understand this monumental change, scientists have looked to Earth's neighbors in the solar system. The Earth's axial rotation is perturbed by gravitational interactions with the Moon and the more massive planets that together induce periodic changes in the Earth's orbit. Peter D. Menalco, the director at the Center for Climate and Life at Lamont Daughtry Earth Observatory at Columbia University, New York, wrote in Nature, one such change is a wobble in the Earth's axis, he wrote. That wobble is what positions the northern hemisphere closer to the sun in the summer, what researchers call a northern hemisphere summer insolation maximum every 23,000 years. Based on research first published in the journal Science in 1981, scholars estimate that the northern hemisphere had a 7% increase in solar radiation during the Green Sahara compared with now. This increase could have escalated African monsoonal rains by 17 to 50%, according to a 1997 study published in the journal Science.
Andy.
Hold on.
Oh, wait, Andy.
Yes.
Andy, I have to go to the bathroom. My stomach hurts.
Okay. I'll continue to read, all right?
All right, just
I'll
guys, hold up.
all right, hope you feel better.
Can I call you back within the next 5 to 10 minutes?
Yes, please. Thank you, Johnny. Feel better.
Oh, right.
What's interesting to climate scientists about the Green Sahara is how abruptly it appeared and vanished. The termination of the Green Sahara took only 200 years, Johnson said. The change in solar radiation was gradual, but the landscape changed suddenly. It is an example of abrupt climate change on a scale humans would notice. Records from ocean sediment show that the Green Sahara happens repeatedly. The next northern hemisphere summer insolation maximum, when the Green Sahara could reappear, is projected to happen again in about 10,000 years from now, or in AD 12,000 or 13,000. But what scientists can't predict is how greenhouse gases will affect this natural climate cycle. Paleoclimate research provides unequivocal evidence to what humans are doing is pretty unprecedented. Even if humans stop emitting greenhouse gases today, the gases could still be elevated by the year 12,000. Climate change will be superimposed onto the Earth's natural climate cycles, she said. That said, there's geological evidence from ocean sediments that these orbitally paced Green Sahara events occur as far back as the Miocene epoch, 23 million to 5 million years ago, including during periods when atmospheric carbon dioxide was similar to and possibly higher than today's levels. So a future Green Sahara event is still highly likely in the distant future. Today's rising greenhouse gases could even have their own greening effect on the Sahara, though not to the degree of the orbital force changes, according to a March review published in the journal One Earth. But this idea is far from certain due to climate model limitations. Meanwhile, there is another way to turn parts of the Sahara green. Of course, it's using desalination plants along the coast, and also the Sahara Desert has a huge amount of water on the ground. There's literally almost an ocean's worth of water under the Sahara. Meanwhile, there's another way to turn parts of Sahara green into a green landscape. If massive solar and wind farms were installed there, rainfall could increase in the Sahara and its southern neighbor, the semi-arid Sahel, according to a 2018 study published in the journal Science. Wind and solar farms can increase heat and humidity in the areas around them, and increase in precipitation could in turn lead vegetation growth, creating a positive feedback loop, the researchers of that study said. However, this huge undertaking has yet to be tested in the Sahara Desert, until such a project gets funding, humans might have to wait until the year 12,000 or longer to see whether the Sahara will turn green again. Isn't that exciting? So, as I said, the Sahara fluctuates between desert and savanna. That's why you found lions in North Africa. Where did Rome find lions? The Romans imported lions from Mesopotamia and North Africa to fight at the Colosseum. So this is the key handle from Britain. Wow. Yeah, and why were lions found in North Africa? Blazer Evie, nice. Anyway, why were lions found in North Africa? A Barbary lion. They're extinct, actually. They're basically is an extinct. It is locally extinct. These lions existed because of the Green Sahara. But as the Sahara Desert, as desertification increased because of the loss of biodiversity due to the collapse of farmland, also being hunted by humans, so a combination of natural climate change due to Earth's axial tilt and then over hunting, they basically got extinct. So it's a combination of natural climate variations and also being hunted to extinction. Unbelievable. Asian lions? That is horrible. What? Wow, isn't that cool? What country? Just I don't go off a little tangent. That's the There we go. There we go. 15,000 lions. So right now, let's go back to Campifligre. Very little earthquake activity actually right now. In fact, almost non-existent. The last earthquake actually occurred a couple hours ago. Small one, probably magnitude 0.2 to 0.4. It doesn't even show up here. That earthquake actually was here. The 0.8 earthquake that is being showed up here is actually this one right here. So based on that, I'm probably going to estimate that earthquake was probably 0.2, 0.3. Anyway, I have to go to bed now. Thank you all for watching, and good night. Thank you so much, Johnny. Good night. Please don't forget to subscribe. I'm trying to get back up to my 1,400 subscriber mark that my last channel had. So please share this channel. I am going to make live streams and videos every day from now on. Thank you, everyone. Good night.